Welcome to the Calculus C section. In this section, we'll be discussing sequences. So first, we'll tackle sequences, which are a list of numbers written in a specific order. So here are the general denotations of sequences. We have A1, which is given by the first term in the sequence. A2, obviously the second term in the sequence. And we have AN, which is going to be the nth term of the sequence, or any term. We have AN plus 1, which is going to be the next term in the sequence, and or the n plus 1 term. I don't know how to n plus 1st term, and the previous term, which is going to be AN plus 1, AN minus 1. My apologies. And so this is important to not get this confused with AN minus 1 as in two separate entities, or AN plus 1 as a separate entity. They're actually, the plus 1 and the minus 1 are contiguous with the N and the denotation of where it lies in the sequence. So additionally, what we use sequences for in Calculus C is to determine whether a function is going to converge to a value or whether a function is going to diverge and never approach a certain value. So if we had something like this, and if we wanted to figure out where this curve, if this curve converges at x equals 3, we can see that if we label our graph 1, 2, 3, that there's a value here where 3 is, there's a y value for where 3 is x, or x is equal to 3, which means that there is a point, it is continuous, and that means that it will converge to a certain point at x equals 3. However, if we had something like where we had another function that we were dealing with. Let's redraw that. Let's say we were dealing with another function, or this was a piecewise function, and we wanted to find out whether these two functions were convergent or divergent, and we wanted to say, okay, at this point, x equals 3, the same point, does it converge to a certain point? Does it diverge? Does it not approach a certain value? Well, we would be able to use our sequence to determine whether what would happen. And so basically, we can try out an example below. So let's say that we wanted to figure out the following sequence for n plus n squared, and we're going to say 5 to 1. And we just want to find the first 5 terms of the sequence. So the first term, we're just going to plug in 1. We're going to say 1 over 1. The second term is going to be 2 over 4. The third term is going to be 3 over 9, and the fourth term is going to be 4 over 16, and the fifth term is going to be 5 over 25. So it's just 1, 1/2, 1/3, 1/4, and 1/5, and that's the sequence. So we can see that these numbers are actually getting smaller and smaller and smaller. So what would actually happen is, when we look at this, if we were to say we wanted to look at n over n squared as it approached infinity, and we start at 1, we can actually look at this and say that, okay, as we get to an infinite value, this n is no longer going to be a factor in comparison to n squared, because n squared is going to grow exponentially as fast. So we can actually say that this series is actually looking like 1 over n, which it actually is. It is actually 1 over n. So when we put infinity in this, we can say that this function is going to converge to a value of 0, which is also depicted here, as we can say that we go from 1 to 0.5, and from 0.5 to 0.33, from 0.33 to 0.25, and from 0.25 to 0.2, and then we're going to keep decreasing. We have 1 over 6, we're going to get 1.825, we have 1 over 7, and we're just going to keep decreasing to a smaller and smaller value, which means that we're going to actually converge to, it won't be a value of 0, we're actually going to converge to 1.5, 1.33, 1.8, so it's going to seem like we're going to approach about 3. But that's not very important. We just know that this series is going to converge and it won't diverge. And that's basically what we use sequences for. So I hope that helps. If you need more assistance, there's a bunch on the website, and thank you.